Okay, so Objective 53, we're going to continue this idea of the unit about similarity and congruence. And specifically in this objective, we're going to talk about proving when triangles are congruent. Remember, congruent means the same size and the same shape. So this is a really important topic in geometry to be able to say that two triangles are congruent. But the question is, what information do we need? And what information can we show that actually proves that triangles are congruent? And here's the kicker. You actually only need 3 corresponding parts to be congruent in order to prove that two triangles are congruent. Remember, corresponding parts means that they're in the same location on two different triangles, the same side or the same angle location. You actually don't need to show that all 3 sides and all 3 angles are the same. There's a smaller point, a smaller number of parts where you can actually stop yourself and say, well, I've proved that 3 are congruent. That means the whole shape is congruent. And there are 4 different, what we call congruence postulates that are used to show that triangles are congruent. And we're going to talk about those 4 things. What is a postulate? It's kind of like a theorem, if we know that word. So a postulate is just a statement that has been proven to work and be true every time. Triangle congruence postulates are represented by 3 letters. So it's going to be like an acronym. You're going to see like 3 letters, and that's how we signify which postulate we're talking about. So depending on what information you have, that's going to tell you which postulate fits. So if you look at these 2 triangles here, they're the exact same size and the same shape. So we have that triangle ABC is congruent to triangle DEF by ... This is where, based on what information we have, we'll use a specific postulate. Now, real quick, I want to make an analogy here. I like to think of congruence postulates for triangles. Think about baseball or softball. If you're up at bat, and there's a lot of ways that you can get out, but depending on what you do, we'll just kind of take a different path to get out. Now, obviously, you don't want to get out, but it happens most of the time. The reality of baseball and softball is like, right, if you get out 7 times out of 10, you're still really, really good. So for example, if you swing and miss 3 times, you'll strike out. That's one way to get out. Maybe you hit the ball, but it goes on the ground to shortstop, and then you get thrown out. Well, maybe you hit the ball on the ground, but it goes to first base, and then you get tagged out. Maybe you hit the ball in the air, and the ball gets caught, so then you fly out. No matter what way you do it, whether you swing and miss, you make contact, you hit the ball here or there, in the end, you're still going to be out. And it's the same idea with triangle congruence. Different information will lead you to use a different postulate. Maybe it's this one, maybe it's that one, but either way, in the end, the triangles are going to be congruent. And that's what we need to prove. So, the first postulate is called side, angle, side. So look at the 3 parts that it uses. It uses one side, one angle, and then another side. And we abbreviate it with SAS. So we have one side, one angle, and then a second side. But you notice that the angle, the way it's written, is in between. So the angle is between the sides. Now, there's this idea in geometry called this idea of what we are given. That means that information is what we are told. It is true and we can accept it as fact. So let's plug in this information and let's actually see what we're then looking at to see what Sideangleside looks like. So I'm going to go, information I'm given is that angle A is congruent to angle E. So I'm going to put an arc mark on angle A and the same arc mark on angle E because they're congruent. Secondly, I'm going to find side AC, and I'm being told that's congruent to side EF. So I'm going to go to side AC, I'm going to put a tick mark. I'm going to go to side EF, put the same tick mark because they're congruent. And lastly, we're told that side AB, which is right here, I'll put a double tick mark because we need to signify it differently, is congruent to side ED, which is also a double tick mark. And now look at what we see. You have a side, an angle, and then another side. And over here, you have a side, an angle, and another side. So we now know that these two triangles are congruent because they follow the postulate number 1, which is side, angle, side. So here's what our congruence statement is. Remember, pick the first triangle any order you want. I'm going to go B, A, C. So, no, let me back that up. I lied. Let's make it easy on ourselves here. Okay, how about we do ABC? Let's just keep it simple. Now remember, if I'm going to start at the marked angle, I'm going to go over to B, which means I go down the double tick mark side and over to C and then back. So I'm going to start at the angle, which is E. I'm going to go down the double tick mark side to get to D, then over and back. So we say these two triangles are congruent by side, angle, side. Okay, let's check out another one. The second postulate is a little bit different. It's angle, angle, side. So you need to take one angle, two angles, and then one side. And notice that the ordering is intentional because it goes angle, and then a side, which is not in between the two angles. It's off on its own. Okay, so let's see what we are given. Angle A is congruent to angle G. So I'm going to put an arc mark on A and an arc mark on G. Angle C is congruent to angle B. So I'm going to go to C. I'll use a double arc mark so that it's different. And on B, I'll use a double arc mark. And lastly, side AD, I'll put a tick mark, is congruent to EG. Tick mark. So, look at what we have. We have angle, angle, side. And here we have angle, angle, side. So, that's one of our postulates that tells us that two triangles are congruent. So once again, pick your first triangle any way you want. Let's do CDA. Now, if I start with the double arc mark, if I start with C that has the double arc mark, in my other triangle, I need to start with the same one that has a double arc mark. So I'm going to start with B. In my triangle, I go the double marked angle to the no marked angle, back to the single marked angle, and then home. So in my second triangle, I need to go from the double marked angle to the no marked angle, down to the single and back. So I must have to do B, E, G. And these are congruent by angle, angle, side. Again, angle, angle, side, side, angle, side. These are just ways to prove congruence based on what information we have. Okay, the third one is called side, side, side. Super simple. Need one side, need two sides, need three sides. Think about it. If two triangles have the exact same side length, they have to be congruent because they have the exact same sides. So perfect. So let's put in some tick marks here. QC, side QC, is congruent to MC, so I'll use a single tick mark. QV, I'll use a double, is congruent to MV. But here's the thing, guys. We don't have any other given information. But if you look at the diagram, what you should notice is that side CV is actually part of both triangles, and it's congruent to itself. So CV, right down the middle, is congruent to itself. So we can use that as the third side, and it shares between both triangles. So let's pick triangle 1. Let's pick some way to name it. We're going to go QVC. Now, we started at Q. We went down the double towards V, down the triple, and then back on the single. So if we start down here, right, the thing that's going to be congruent to Q is going to be M. We need to go down the double, across the triple, back on the single. So this should be named MVC. And these are congruent by side, side, side. And the last one, there are 4 postulates. The last one is called angle, side, angle. And it's important that the side is in the middle. That's why it's written like that. So let's see what we're given. Angle A is congruent to angle C, so we'll put an arc mark and an arc mark. Side AE, put a tick mark, is congruent to side EC, put a tick mark. But once again, we're only given 2 pieces of information. But if you remember that when you see something where 2 triangles touch at a certain point right there, and they create an X, we know that angles on opposite sides of the X are congruent. So we actually also know that this angle here is congruent to the angle right across from it. Because of what we've learned before, it's called vertical angles. So now look at what we have. We have an angle, a side, and an angle. And we also have an angle, a side, and an angle. So there we go. That's our last postulate. ASA, angle, side, angle. All right, let's name the first triangle AEB. So if we start here at A, it has the single arc mark, which means we need to start here at C, which has the single arc mark. We go down the single tick mark line across and back. So we need to go down the single tick mark line across and back, which means we need to name this triangle CED. And they are congruent by angle, side, angle. Okay, so let's do a few examples. It's the best way to try to get used to doing this. And the proof is in the snack pack. No, that's not right. Proof is in the pudding. Okay, this is where it's really important to mark up your diagram. Put in your tick marks, put in your arc marks exactly where they say. Okay, given UV is congruent to XV. So I'm going to find side UV right here, side XV right here. Hopefully we see the 2 triangles, triangle 1 and triangle 2 down here. All right, now TV, so let me find TV, which is this line here. We'll use a double tick mark, is congruent to WV. This is a double tick mark. That's the only information we have, so it must mean that there's another thing that's staring right in front of us, and we just got to go find it. And look, remember, when 2 triangles touch at a point and form an X, the angles that are opposite are congruent. So let's think about what postulate we have here. We have a side, an angle, and a side, and we have side, angle, side, with the angle in the middle. So we must be talking about side, angle, side here. So that should help us eliminate. So side, angle, side, good. Angle, side, angle. Nope, because that's not what we're given in the diagram. And same thing, angle, side, angle, no way. So now it's just a question of which of these 2 triangles is the correct ordering. So watch. Triangle TUV. So we start here at T, we go to U, down to V. Is that the same as, so TUV means we go down the side with no tick mark, across with 1, and back with the double. Let's see if this agrees. Let's start at W. We're going to go to X, which is down the side with no tick mark, over the side with 1 tick mark, back along the side with 2. Is that the same thing we said? We said no tick mark, down to 1, across at 2. So it follows the same pattern. So these then is the correct way to name those 2 triangles. Okay, we'll keep going. I know it helps to do a lot of examples here. Okay, given that triangle DEF, so the whole big triangle is equilateral, which means all the sides are the same. So I want to put that information in right away. Okay, what else do we know? DG is congruent to FG. So DG here is congruent to FG here. And hopefully what we notice is that we really don't want to focus on this bottom piece down here. Is look, triangle 1 and triangle 2. They share that third side because they touch. So what we're looking at here, people, is an old-fashioned case of side, 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 side. So it looks like we are relating these by side, side, side. So that's the wrong postulate, and that's the wrong postulate. So now let's look to make sure. Here I gotta erase this tiny bit so we can show G there. That's good. Go back, double, double. Okay, so let's check this triangle DFG. That's this triangle right here. Well, that's not even one of the triangles that we're talking about. We're talking about triangle 1 and triangle 2 over here, so that's no good. So DFG doesn't make any sense. So in this case, it's got to be C. Determining which postulate we use is really the first important part. That'll help us eliminate answers. Okay, so given the markings on the diagram, state the theorem or postulate that proves that triangle ADB, so this triangle here, and CDB, okay, so triangle 1 and triangle 2. Well, what are we given so far? Well, we should notice that we're given a side and another side, and anytime two triangles touch, they always share that third side. So by this, it must be side, side, side. What's the theorem or postulate that proves they're congruent? It's got to be side, side, side. Okay. Number 4, given the markings, prove that triangle ADB, which is this number 1 here, and CDB, same thing, this number 2 here. Okay, well, what do we have so far? Let me back that up. That wasn't very neat. There we go. C, D, B. That's the second triangle. Well, what do we have so far? We're given a side, and you can see right here we're given an angle and an angle. Once again, when two triangles touch, you can always use that third side. So then what postulate? Well, this triangle over here uses side, an angle, and a side, and this one uses a side, an angle, a side, with an angle in the middle. So the postulate we use must be side, angle, side. Okay, given that HI, so I'm going to put a mark on HI, is equal to JK, and IJ, which is here, is congruent to KL, which is there, which of the following is true? Okay, so let's think about what we're given. Here's the first triangle, here's the second triangle. We have a side, we're given a right angle and another side, and then we have a side, we're given a right angle and another side. So it looks like we are using side, angle, side with the angle in the middle. So we can eliminate these options. So now the question is, well, which ordering of the triangle is appropriate? All right, so we triangle HIJ. So we start at H, we go up the side with a single, down the side with a double, and then back because we go from H to I to J. And in KLJ, we start at K and we go to L, so we go down the double, across the nothing, up the single. But in this one, we went up the single, down the double, across nothing. So that's not the right order. So it must then be B. And let's just check it. We go start at H, we go up the single, down the double, across nothing. If we start at J, we go up the single, down the double, across on the unmarked line. So it checks out. Okay, we got 3 more examples. If angle ABD, remember this in the middle is always your vertex. So angle ABD is right here at B, and angle CBD, C to BD, so it's this angle as well. If those are equal, and angle ADB, so this is our vertex, angle ADB is right here, we'll do a double arc mark, and angle CDB, same thing, C to D to B, so this must get the double arc. Which statement is true? Well, once again, any time that they touch, you can always use the line that connects them as a side. So we have an angle, a side, and an angle. And in the bottom, we have an angle, a side, and an angle. So it looks like these are going to use angle, side, angle. Nope, nope, nope. Cool. There's only one option that uses angle, side, angle. So that must be it. Okay, this is an interesting one because hopefully what we can see is that these triangles overlap. So I'm going to kind of pull these triangles apart, and hopefully we can see that this triangle, if we were to actually slide these triangles apart as such, this is a tough one. But if we can kind of pull these triangles apart and pull this one this way and this one this way, that they would slide apart. So P is up here, Q is up here, and then this is R, but this one is also R, and then this one's O, and this one's also O, because really they overlap. So here, I'll try to, this is one of the triangles, and then this here is the other triangle, and you can see that they overlap there on the bottom. So let's just see what we're working with here. Okay, PR is equal to QO. So PR, and put a tick mark, equal to QO. OP, put a double, is equal to RQ, put a double. Now, what you notice, guys, is that when they overlap, look at this right here. They both share this side, OR. And look here, OR, OR. Well, the side OR must be congruent to itself because it's the same thing. So look what we have here. We have a side, and a side, and we have a side, and a side. A single tick mark, a double tick mark, and a triple. So they must use side, side, side. So we can eliminate this option because this uses angle, side, angle, and this uses side, angle, side. So now let's see which triangle is the correct ordering. So this is triangle OQR. So you start at O, you go up the single to Q, down the double, and back on the triple. Let's see about RPO. We start at R, we go up the single, down the double, back on the triple. That sounds like the same order to me. Last one. So we are given that BC, put a tick mark, is equal to FE, put a tick mark. And we're told that BC, this is interesting, BC is parallel to EF. Wowee. So I'm just going to look. So these lines here are parallel. And this goes way back to when we were talking about a transversal. My gosh, we're going to bring this back. Okay, so when two parallel lines are cut by a transversal, we know a couple properties about their angles. Alternate interior angles are congruent. So look, this angle here and this angle here are on alternate sides of the transversal, but they're both on the interior of the parallel lines. And the same idea goes for if this line was the transversal, then you would have alternate interior angles here and here, because they're on alternate sides of the transversal, but they're interior. That's bringing it way back, guys, way back. So let's look at what our two triangles have. Well, it looks like we have an angle, a side, and an angle. And here we have an angle, a side, and an angle. A single angle marker, a side, and then a double angle arc marker. So it looks like we're going to be using side angle, side, angle. So unfortunately, we can only eliminate one because all of these are going to use angle, side, angle. So let's check it. So triangle BCD means we start at the single angle arc marker, go to the double, down, and then back. What about FED? So we start at the single angle, we go across the single arc, up, and then back. So we kind of got lucky. That was cool. So angle B is the single arc mark, angle F is the single arc mark, so those are both in first position. Angle C is the double arc mark, and angle E is the double arc mark, and those are both in second position. And then angle D is the same. So these match up. So we got lucky. Awesome. Okay, so this is really tough stuff. This is a really, really important topic in geometry, but it's really tough. So my suggestion is do your best to, if you can print out your notes, that's great. If you can print out your practice, that's even better, because you need to draw in all the information you're given. And then you can decide what information do I have that will tell me which postulate can prove the triangle is congruent. Do I have side angle side? Maybe I have angle side. Maybe I have side side, or maybe I have angle side angle. Give it a shot. See what you guys can do.